So now that we have a toolkit of graphs that we know, some just the parent graphs of a lot of different types of graphs, today what we're going to do is we're going to do transformations of those graphs. So it is very, very important that you thoroughly understand those parent graphs to be able to do today. When we look at graphs, we oftentimes will do analyzing of those graphs, and these are just some of the ways that we do look at them to analyze them, because sometimes there's something going on real world wise that this is what we would need the info for. So domain and range, I'm just kind of recapping what these things mean. I'm not really writing anything, and you can write anything that I say here that you don't already know. So the domain is always going to be your possible X values. I usually look at a graph and I think of how far left does it go and how far right does it go. And that's what my domain will be. And my range are all my possible Ys. So I'm looking at how low it goes and how high it goes. The intercepts are where it touches the X and the Y intercept, or the X and Y axis. Min and max, these are always considered the relative min and max. We don't usually write the word relative or even say it, but we will always imply we're talking about relative min and max, which means only peaks and valleys in your graph. We are never going to talk about the min or max being infinity, just peaks and valleys. Okay, another thing that we look at is where the function is increasing and where it is decreasing. So when is it headed upward? When is it headed downward? Now, as we're doing that, we're always listing the X values. So even though it feels like you're going up until you hit a Y value, it's not that Y value that you list. You list the X values where that's occurring. All right. Even and odd, I don't know if you remember this from college algebra, but even functions will always have y-axis symmetry. Odd functions always have origin symmetry. And for today, we're just going to kind of look at it and just see what, if it jumps out at us, whether it has symmetry or not. And then the other thing that you need to be able to do is be able to find a y value if I give you an x value. So can you plug it into the function? Or vice versa, can you plug in a y value and find the x value? And when I say that, oftentimes I'm going to be referencing like on the graphing calculator. Can you do that? So you do need to be pretty knowledgeable of your calculator. It's going to be hard for me to do this on a video, so there are some special videos for graphing calculator features on the spreadsheet if you want to look there. But we focused on this menu. If you hit second trace on your calculator, it will take you to the calc menu. And these are 4, or really it's 5 because the min and max are different ones. But these are 5 different features of the calculator that we use a lot. Value is great. If you want to plug in an X value, it'll tell you the Y value. So this is when you already know the X. The zeros, remember that's a fancy math word for the x-intercepts. So anytime I need to find the x-intercepts, I use that. Again, we're talking relative min and max here. And then the intersection is if you had 2 different graphs going and you're looking to where they touch or where they cross. So I gave them in class this big messy equation, and we used our graphing calculators to answer or to analyze this function. Now, the graph I gave you, or that I have here, is what it looked like. And then I went in and I did min and max. I sometimes do that very first because I need those values to do a lot of the other stuff. So this ended up being a peak right here and a peak right here. And you can see by my ordered pair that it is symmetrical. And then it kind of, it's like an M, like the McDonald's M or something is what it did. Now I did have to zoom in to get it to look like this because it was kind of tiny. All right, so given this graph right here, let's talk about all the features of analyzing. So domain and range. So I'm looking at my graph for domain. It's how far left does the graph go and how far right does it go? And that would be negative infinity to infinity. But your range is not that. Your range is how low it goes. Yes, that's negative infinity. How high it goes would just be this y value right here. That's the highest it gets at 0.53. So domain, negative infinity to infinity. Range, negative infinity to 0.53. All right, so the next thing we're going to do is look at the intercepts. Now, the y-intercept we're lucky on because when you look at the graph, you can see that the y-intercept, where it touches the y-axis here, is just going to be right here at 0, 0. So that would be your y-intercept. Now, it actually is also an x-intercept because it happens to be the origin. But that is not the only x-intercept. We have this one here where it crosses the x-axis and right here. Now, because the graph is symmetrical, I really only have to find those once. I haven't found those yet. I was going to walk through that. I know if you have your calculator, that's great. You can kind of follow with me. So I go to that second trace menu, and I'm going to go to 0 because those are your x-intercepts. And then it always wants you, if you look at the bottom left, it'll say left bound. It's saying like they want you to move your cursor left of the x-intercept you're looking for. So my cursor happens to be about right here right now. So I already am left of this one. So I'm just going to go find this one here. So I'm just going to press enter. I'm left of it. And then I have to scooch right until I am right of that x-intercept. And I put enter. And it gives me these two bars saying, all right, you want the x-intercept that falls in between here and here? Yeah, that's what I want. It lets you make a guess. I usually just press enter. And it shoots me back what the 0 is. It's 0.693. So this is symmetrical. So my x-intercepts will be a 0 and a plus or minus 0.693. All right, min and max I've already found. Well, I take that back. I have found them with my calculator, but to list it, remember you're talking about your relative min and max, which means any peaks or valleys. So I have one valley, it's that 0, 0 where it came down and came back up. So there is a minimum of 0, 0. And then the maximum, I actually have two of them. And oops, I didn't get that other 0 there. Okay, and then your maximum is going to be plus or minus 0.25, 0.53. Now, that usually is representing something in the problem, both the x and the y. So I do write the min and max as an ordered pair. And if I'm doing some sort of application problem, I'm actually going to write a sentence that explains what that represents. All right, let's move on to increasing and decreasing. Remember that you're going to list the x values where the function is increasing or decreasing. So I'm looking at my graph right here. Oops, right here. So right now, as I start, I am headed upward. So this is an increasing function, and it's increasing, 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 increasing until I get to here. Now, at this point, my x value is negative 0.25, and that's what I'm going to write for increasing. The function is increasing from negative infinity to an x value of negative 0.25. Then the function immediately starts decreasing. So now I'd write decreasing. And it's going to decrease from that same spot, negative 0.25, until it gets to that 0, 0 mark. And that's an x value that I'm writing. Then it's going to start increasing again. And then it's going to decrease again. So it's going to increase until I get to this x value, and then it's going to decrease from then on. So my increasing, we don't really do that U thing here. We just kind of put a comma between the sections that it's increasing and decreasing. We also always use parentheses. We don't get caught up on the bracket versus parentheses on increasing and decreasing parts. So I'm going to say that this is starting to increase again from 0 until I get to a positive 0.25. And then it's back to decreasing from that 0.25 to infinity. All right, when I look at my graph, I can see that it has beautiful y-axis symmetry. Y-axis symmetry makes it an even function. And then to do f of 5, then I am going back to my second trace menu. Now, one thing you do have to know about the value, because I'm getting ready to use value, is that it does have to fit within your screen. And since I zoomed in on my screen, this value of a 5 is not really within the screen size that I have. And my calculator will give me an error. So if you get an error on that, it might be because your window is too small for it. So what I'm going to do is I'm going to do a quick zoom standard, number 6. And that takes me back to a 10 by 10 grid. And then I'm going to go to a second calc and do value. And I just hit 5. F of 5 means put 5 in for X. When I did, I got a negative 31.58. All right, this one says the other direction. Find the value of X such that the Y value is negative 9. There isn't a nice button to find the X when you are given the Y. Like that value button is really handy, but I don't have an option here. So what we do in this scenario is we go to Y equals, and I already have something in Y equals. I have my function there, but I'm going to go down to Y2, and I'm going to say, hey, I want Y to equal negative 9. And then when I graph it, it's going to give me a horizontal line at 9. And what I can do then is now I'm going to go use that intersection button. I can find the intersection of my curve and my horizontal line. The second trace, number 5. And now the directions at the bottom left say first curve, question mark. Like, what do you want me to find the intersection of? It automatically is on Y1. You can see that up at the top. I just press enter. Yeah, that curve. And it will then immediately toggle to Y2. Yeah, that's my second curve. So I press enter there. It does let me make a guess. In this case, the reason they're wanting you to make that guess is in case there's more than one, and there is more than one intersection. So you're supposed to scoot your cursor over close to the one that you want. Now, because of the symmetry, it won't really matter. I just went over towards the right. But what I ended up with is a 2.695. And again, because of the symmetry, it actually would also be that at a negative 2.695. So I'm going to do plus or minus. Okay, that's a little tricky to try to teach you how to do that when you're not looking at what I'm looking at. It's more than anything, I'm just kind of reminding you about some things. If you have issues with your calculator, please come see me during flex time. All right, so what we've been working on is analyzing graphs. Now we're going to move on and we're going to look at transformations of our graphs from our toolkit. So this is kind of the generic format that we use to show that a function can transform. And it looks pretty familiar from a parabola that you're probably pretty familiar with. So what does look different here is this F in here. It's probably a different notation than you're used to, but this F itself doesn't really mean anything. But it's just saying, hey, take this F function. And the function might be an absolute value. It might be a square root. It might be a quadratic. It can be any of those functions, and this whole process is going to be the same. So this A value, just like in a parabola, this A value will do any vertical, stretch or shrink that might need to happen. The bigger A gets, it stretches. If it's a fraction, it will shrink. It also, if it happens to be negative, then it will reflect the graph as well. All right. Now, if this is a quadratic, then you would see a squared right here. If it was a cubic, you'd see a cubed. If it was a square root, you would see like a square root over the whole thing. So that is what we consider like inside the parentheses or inside the grouping symbols. And anytime you're inside there with the X, that is going to affect you horizontally because it's with the X. And you'll always move it. Well, I'm not even going to write horizontal. I'm just going to write left and right. It moves it left or right. And anytime you're inside the parentheses, and I think I'm going to erase something here. It's not really this X, it's the H value. That arrow that I wrote didn't really look right. It's the H value, tells you how much to shift your graph left or right. And inside the parentheses or the square root or the absolute value, you always do the opposite. So if it's a plus sign, it feels like it should go right, but it's going to go left. All right, last one, the K value out at the end is shifting you up or down, and you do what it says because it's outside. So a plus sign is going to go up. All right, now again, you have to know your toolkit really, really well to do this lesson. So make sure you know it and have it out handy if you maybe don't. All right, I'm going to start with kind of a funky, weird graph that's not from our toolkit, and then we'll jump in and look at our toolkit. But you can see this graph looks like it's actually looks like it's a piecewise function. You have a piece of a parabola, then you have this piece of an absolute value, but they're merged together right here. And the transformations that I'm doing here are sort of these generic transformations with this function f that's over here. This is my function f. Here's what I want to do to it. And I have to do these left to right. So the first thing I'm going to do is I'm going to take this negative. That's going to be a reflection over the x-axis. So it reflects it like, I say over the x-axis, but it really is more like it flips it upside down. And so it reflects vertically is what's happening there. Reflects it up like over the x-axis. The 3 is going to be a vertical stretch. That stuff is outside of the grouping symbol, and so it affects your y value. Anything inside the parentheses or the grouping symbol, like this right here, that's going to move you or affect your x. That's just going to move me, do it the opposite, remember, so I'm going to go right 1 unit. All right, so here's what I do. To take this funky graph, I'm going to grab this ordered pair right here, and I'm going to do all 3 of these transformations. And then I'm going to do this one and do all 3 transformations, and then this one and all 3. Okay, so here we go. I actually am going to start with, and just use my laser pointer here because it's going to be easier probably to do that. So I'm going to take this -4, 0, and it's right here. All right, now the first thing I'm going to do is I'm going to reflect it vertically. Now, maybe this wasn't a great one to start with because I'm right here on the x-axis. If I try to reflect it, it's really just going to stay where it's at. So that one just stays put. That doesn't do anything. Then it says to do a vertical stretch. And I probably should have said that we're going to vertical stretch by 3. So I'm going to go 3 times farther vertically off of the x-axis than I am right now. Well, the thing is right now I'm 0 off of the x-axis. And if I stretch that times 3, I'm still 0 off of the, because 0 times 3 is still 0. So this thing doesn't really do anything either. But finally, right 1. I can do that. I'm going to take my ordered pair there, and I'm going to go right 1, and it's going to land right here. Okay, kind of a weird one because it was on the axis. Let's try this point up here. This one will have more going on. -2, 4 is where it starts. So it's right here. First thing you have to do is reflect it vertically. So I'm going to flip it down. If it was up 4, now it's going to be down here 4. All right, now I'm going to stretch it by 3. It is currently 4 units off of the x-axis. I have to stretch it vertically 3 times that. So I'm going to end up 12 off of the graph, which is a little bit beyond what I'm supposed to have there, but it's okay. It's down here. Got it? And then the last thing I'm going to do is go right 1. And then I can finally put my point actually there. All right, let's try again. The origin right here. Oh, I'm on my x-axis again. So trying to reflect this vertically, it's not going to reflect, it's not going to stretch, but it will go right 1. Next point, I'm going to grab this 2, -2. 2, -2 is right here. First thing I'm going to do is reflect it vertically. So since I'm down 2, it's going to jump up here and be up 2. Reflected vertically, then I'm going to stretch it by 3. I'm currently 2 units off of the axis, so I'm going to do it times 3, so that's going to be 6 units off of the x-axis. And then move it right 1, and that's where that point will be. Land on 3, 6. All right, last point is this 4, 0, again on the x-axis, which means it will not reflect. It will not stretch, but it will move right 1. So it was at 4, 0, now it's going to be at 5, 0. And then I go ahead and graph it. Make this curvy. This is that parabola piece that got stretched. And then I have this pointy piece is the absolute value piece. And that does all 3 of those transformations. All right, so in class, I had the class do the other one, but that's hard, I know, for you when you're just watching the video. So let's give it a shot together. I've given you some different things here. This 1/2 is now inside the parentheses. That's getting multiplied by the x rather than it being outside like the -3 was. So that means it's not a vertical stretch or shrink, it's going to be a horizontal because it's inside with the x. The other thing that's kind of weird is that it is inside the parentheses, so we always do the opposite. So a 1/2 feels like that would shrink it by a half. It actually doesn't. It's going to be a horizontal stretch by 2. If it was a 1/3, then it's stretched by 3. All right, so horizontal stretch by 2. And then this is going to just take it up 4. Sorry, up 4. All right, that's only 2 transformations. This might go faster. Here we go. I'm going to take this ordered pair right here at -4, 0, right here. The first thing I'm going to do is I'm going to horizontally stretch it twice as far. So right now, and now I'm thinking horizontally stretch. So now I'm out 4. I'm going to stretch it twice that. I'm going to end up out 8. And then I'm going to go up 4. Next thing, I'm going to grab the next point here, up there. It is currently off of this axis, left 2. Right here. So I'm going to stretch it twice as far horizontally. So it's at moved over 2. Now it's going to move over 4. And then I have to go up 4 right here. All right, now let's use the origin. Origin cannot stretch because it's at 0 times 2 doesn't do anything, but it can go up 4. Okay. Did you see that I kind of was bad? I was sitting there hesitating. Sorry, this guy here is a little bit off of what he should be. Can I erase that? Yeah, there we go. Okay. Sorry, he counted it, but I think I just didn't pay close enough attention. So I'm up here at 8, but I'm right there. All right. Now I'm going to go grab this point 2, -2. I'm going to stretch it 2, so it's to the right 2, so I'm going to stretch it twice as far. So now it's over at 4, but then it's also going to have to go up 4, so it's going to land right here when it's done. All right, last one. This one here is at 4. I'm going to stretch it twice as far horizontally, so it's going to be at 8, and then it has to go up 4. So 8, 4. All right, here's my parabola piece. Here's my absolute value piece. All right, what do you think? Do you remember that from college algebra? Okay, moving on to our toolkit. Now's the moment of truth. Do you really know your toolkit well? This is an absolute value. What I'm going to need you to know is that, oh, an absolute value is a V. It should just come to you. You should just know it's a V. It has a vertex at the origin, and the table for an absolute value, for the parent graph of an absolute value, would just go like 1, 1, 2, 2, 3, 3, 4, 4, maybe 10, 10. It just has this nice, beautiful slope of 1. You need to know that because we're going to adjust that. So the way I read this is that your y values, because f of x is y, your y is 3 times what it would normally be. So what I do is I take the y values, and because remember that's a vertical stretch, so it's going to take those y values all times 3. So that's going to stretch it upward more. The other thing then I want to look at is where my vertex that was at the origin is now going to shift. So what I want to do is I want to get my vertex in the right spot, and then I'm going to do this stretching. So this would mean that it needs to go right 2 and down 5. So I'm going to plot right 2, down 5, and that's going to be my new vertex. And then I'm going to look at my table, and normally it would be over 1, up 1, but now it's going to be over 1, up 3. And then I know it's always symmetrical, so I'm going to have that same point on the other side. Okay, normally from the vertex you go over 2, up 2. I'm going to go over 2, up 6. And put its symmetrical point on the other side. Let's do one more. Normally it's a 3, 3. Now it's going to be over 3, up 9. And that's probably enough to kind of get a good shape in there. And we've got it. There you go. Now, as far as the analyzing, I was just throwing options out at the students today about like, okay, I don't know, what's the domain? Okay, so you would look at that and say, or the domain and range, probably I'd give them both. So the domain, it goes forever left, it goes forever right. So it is a negative infinity to infinity. But your range is not that. Your range, what is the lowest it goes? -5. What is the highest it goes? Infinity. Oops. It actually touches -5, so we want that to be a bracket. Like that. All right, I'm going to try another one. This one is not absolute value. This one, you can tell, has the x squared, so this is a quadratic. So right now, you should be thinking, oh, that's going to be a parabola. Okay, good. I knew you were thinking that. The other thing that you need to know then is what the parent table is for a quadratic. So typically, I would, from the vertex, go over 1, and then I would go up 1. And I'm just kind of plugging this 1 into my function. If I plug a 2 into my function, I'd get a 4. If I plug a 3, I'd get a 9. If I plugged a 4, I'd get a 16. I'm just squaring. That's what this function does. It squares it. You should know that table off the top of your head, because then I'm going to come try to transform it. And what this is saying is that the y value is half of what it would normally be. So that means I've got to take these y values right here, and I'm going to take them all times 1/2. And just like last time, I need to get my vertex in the right place. So I can tell the shifting here. It's going to go right 2, down 4. So I go to my calculator, or to my graph, go right 2, down 4. That's my new vertex right there. From the vertex, I normally go 1, 1, but now I'm going to go over 1, up 1/2. Okay, that's not going to be very nice, probably, but I'll do it right there and there. Let's go to the next one. It might be a little bit better. Normally, I'm going to go over 2, up 4. Now I'm going to go over 2, up 1/2. Always coming from your vertex. Over 2, I'm sorry, did I say that wrong? Over 2, up 2, because it's half of 4. And always putting in that symmetrical point there also. Okay. I'm just going to skip over the next one because I know it's not going to come out very pretty, and I'm just going to stretch out a little bit farther. Instead of going over 4 and up 16, I'm going to go over 4 and up 8. From the vertex, 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. There it is. And then if you can kind of track that over here, it would land right there. All right, I could go one more, but it's probably going to end up off my graph, so I'm going to call that good, and I'm just going to graph my parabola in. This is a lot harder to do if you don't know your table and you're recreating that table every time. All right, let's analyze this one. Let's do the relative min and max. All right, there is definitely a valley in this graph. It's right here. This is a pretty ugly parabola I drew there, but okay, it has a minimum right here. So I would write the minimum is whatever that would be, which was right 2 and down 4. That's my minimum. Now, as far as a maximum, there is not a peak. I mean, they shoot off to infinity, but I said we're not going to ever do infinity as the maximum. So this one only has a minimum. It doesn't have a max. All right, same old thing. We have a cubic this time. In your mind, do you know what a cubic looks like? Okay. Hopefully you're saying it's that snaky thing. I don't know, whatever you use for to remember what to call it. So really what I want you to also know, though, is your table. So you're always going back to the parent function, y equals x cubed in this case. If you put in a y, you'd get a 1 back. If you put in a 2, you get an 8 back. If you put in a 3, you'd get a 27 back. Okay, we're going to be off our graph pretty fast here. But what I'm doing is I'm going to go back up here and say, all right, my y values are -2. Oh, wait, negative. Okay, so all of these have to get multiplied by a -2, which means that it's going to actually flip it. So do you recall that the negative is going to reflect it vertically? Right. The other thing I want before I get started here is to go ahead and plot the shifting that happens. Now, it isn't really, your graph looks like this little snaky thing, and it's not really like a vertex, but it's kind of this key point at the origin that you're shifting. Now, inside here, this is your X movement. You always do the opposite. So I'm going to go right 4, and then I'm going to go down 1. So right 4, down 1 takes me to here. That's my new origin. All right, now from there, my table tells me I would normally go over 1, up 1. But now I'm going to go over 1 and down 2. So from that spot that I just plotted, over 1, down 2. Now you should know from the parent table that it has an opposite point that's not like right across from it. It actually has origin symmetry, so it's going to actually be up there. All right, we're going to try one more. We're going to be off our graph fast. Not over 2 and up 8. It's now over 2 and down 16. All right, from the origin again, or my new origin, I'm going to go right 2, and down 16. Well, good grief, that's way off my graph, way down here somewhere. And my matching point would be way up here somewhere. Okay, I'm done then. I've got what I can. And so then I'm going to make this nice little wave in here. And that's your graph. All right. Analyzing. Let's do, what do we want to do? I'm going to skip this one because it doesn't really have anything interesting going on. Let's try the next one. All right, this is our last one. It is a rational. The rational, if you will recall, is also called the reciprocal function, but the reciprocal really only is a good word for it when it's the parent graph, but it's the one that does this thing. And it has asymptotes in it. That was bad. Let me read. Well, that's fine. That's just my practice one. So think about what that graph looks like. And then what I'm going to do is I'm going to shift it. This down here is not in parentheses, but it is still separated by this fraction bar here. So even though the parentheses aren't there, it's still with the x. We're still going to do the opposite. So this is going to take it and move it right 3. This is going to take it and move it up 2. And what it actually is taking with it, well, it takes everything, but it's these asymptotes that I'm tracking. That asymptote is going to move right or left. This asymptote is going to move up and down. All right, so I'm going to go right 3. So that means my vertical asymptote is going to actually be here now. It went right 3. And then my horizontal asymptote went up 2. So it's going to go right here. And then I pretty much just have to graph in my hyperbola. Now, if you'll recall that your key points that you're looking at from your parent table were like right here at this 1, 1 mark and down here at this 1, 1 mark. Now, that starts to pull away as this number starts to change. Now, honestly, I don't get too worked up about it. If it starts to get pretty big, then just make sure that your graph starts to pull away a little bit from this 1, 1 mark. What I do care about, though, is if it's negative. If that is negative, these two branches of the hyperbola, that graph, go to the opposite corners, and you'd be putting them here and here. This is not negative. That's not happening. So I'm just going to put it in. It's even a 1, so it's going to hold its 1, 1 mark right here and here. And I'm just going to go approach those asymptotes. We've got it. All right, let's do some analyzing on this one. Let's do some increasing, decreasing on this one. So if you look at the function, you start at the far left and you're just trying to track it and see, is it going up or is it going down? Yep, it's going down, 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 down. That whole time it's headed down. So that I'm going to say that this is a decreasing function from negative infinity until you get to 3. Remember, you're doing x values, and that's where that asymptote is. Also, on increasing and decreasing, we always do parentheses. All right, then it starts up here. But look at what it's doing. It's decreasing. It's still decreasing. It's decreasing, decreasing, decreasing forever. So it really is a continually decreasing function. There is no place that it increases, but I do need to kind of insert that break because there was a break in the graph. So I'm going to say it's decreasing from negative infinity to 3 and also decreasing from 3 to infinity. Okay, that's a kind of a nice little sampling. Hopefully that will help. Go give it a try.